Assalamu alaikum. In this video, I will show you how to export an URDF file using Fusion 360. In the upcoming videos, I will show you how to use ROS through our project. We thought it would be hard for someone who's still learning ROS to use the whole project as a start. So we are going to split this project into two parts. The first part will be a robotic arm manipulation, and the second part will be a navigation. So our first part will be dealing with this robot arm. It's actually designed by BCN3D Movio. It's open source and totally free. And we are using this guy plugin. It's a URDF exporter. And I will show you how to export an URDF, a correct file from the first try. URDF is a short for Unified Robotics Description Format. It's an XML file format. Why ROS needs this file? URDF describes robot physical description that ROS need, like mass, inertia, collision. It contains XML element like link and joint, and it's called XML tree, which consists of parent and child. URDF describe all the things about the robot arms that don't change, like how long are the links, what are the joint relative position to the link, and how the joint can move. But it doesn't describe where is the arm in a 3D space. ROS needs this information, so we use a TF package. It's a short for transform. It tracks multiple coordinate frame over time and lets you track the position of the robot arm in a 3D space. It shows you the relative position of each frame relative to one another over time. In short, TF is a dynamic and URDF describes the robotic arm as a static. If you are using TF with navigation, you will need to consider the following. You will need to track the location of your base relative to the start point. To be able to localize your base, you will need to track your start point and base relative to the map itself to be able to navigate through the map. URDF contains the following information: link position and inertia and mass, joint position and type of joint movement, and collision. Collision is usually used to protect the link. The URDF tree structure uses parent and child. A parent can have infinite number of childs, but a child can only have one parent. And between the two links, there will be a joint. The joint will have a joint origin relative to its parent link. The joint origin is very important. It will describe the exact location of the joint between the parent and the child. If you have an incorrect joint origin in the URDF file and I have two links and I want to rotate link 2 relative to link 1 around the joint origin, it will produce incorrect link 2 position because link 2 will rotate around the incorrect joint origin. But if I have a correct joint origin and link 2 will give me a correct link 2 position because the joint origin between link 1 and link 2 is correct. TF will give me a relative position of one frame to another. So if I move link 3, it will give me a relative position of link 3 relative to the whole arm. But on the other side, the URDF doesn't change because URDF is a fixed and TF is a dynamic. In the next video, we are going to visualize a transform tree in RViz to visualize a transform frame, and we are going to visualize it in RQT. It's a runtime tool to visualize the frame being broadcasted to ROS. This figure represents a transform tree. The links are represented by circles and the joints are represented by arrows. The head represents the child, the tail represents the parent. So link 0 is a child of a base link, and so on. When making a joint, you can simply click Joint and select component 1 as the child and component 2 as the parent link. But for some reason, this method is not working anymore. Maybe Fusion made an update that's not compatible with the URDF exporter anymore. You need to select Joint Origin. Joint Origin lets you select the exact location of the joint between the child and the parent. So let's say that I want this pulley to rotate around this motor, and I will select the surface, and I will just move the joint down by 10 millimeter and click OK. If you notice that the axes of the joint origin are matched with the axis I have here to my frame, now I will make a normal joint and select the pulley and select the motor. So when selecting the parent, don't just select any place like this. If you see, I have another origin and it's very different from the joint origin that I just placed. So you just need to select the origin that you placed like this. And specify a motion, revolute, and OK. So this method will produce an exact joint origin around this point that you just specified. Before making an assembly to export your URDF file, you need to know the coordination system that will be shown in RViz and Gazebo. X represents the forward direction, Y represents the left direction, and Z represents the top. And the origin is the same origin of the center of the frame in RViz and Gazebo. This coordination system is very important when dealing with navigation, because you need to make your mobile base facing forward direction. But when dealing with a static object like a robotic arm, the direction may not be very important because it's not going to move around. You don't need to make a full assembly of the robotic arm. You just need to make a simplified one to reduce the computing power. In the next part, I will assemble the robotic arm and I will add a joint limits, and I will specify a material for each link. Before exporting the URDF file, you need to unground the base link and edit the name to base link. Remove the capture history. Then select add-ins, script. After downloading the URDF exporter, click add and select the location and then run it. You will select a folder and that's it. Just remember, don't save this file. It contains an old component. You don't need those, so just click exit and don't save your file. We will access the URDF description, the file that the URDF exporter made from Ubuntu.